In today's talk, we're going to look at three key operations management concepts that are applicable across all industries and sectors. We're going to look at one of the most dangerous myths and assumptions in operations management, 100% capacity utilization. We're going to look at the impact and power of the constraint and managing around the constraint in your business operations. And we're going to look at value, how the value that you and your business operations deliver is probably far more nuanced than you might realize, and how you can use that to your advantage. We're going to start off with a myth, a fallacy, a huge pitfall of operations management, something that sounds so innocent, so wholesome, that it often passes as a truth of business, but it's not. Maximum utilization, 100% capacity utilization, more output, more sales, lower costs, everyone and everything busy all the time. But 100% capacity utilization can be disastrous. Many businesses that are casually aiming for it are only spared its consequences by their inability to achieve it. I'm not talking about burnout or fatigue or unplanned maintenance. Those are all valid, but nothing to do with these other consequences that you will suffer. We're going to consider one of the most important decisions how you operate yourself or your operations in choosing how busy you should be. Many business operations are trying to do as much as possible. Most definitely not all, but many. They are therefore trying to operate at their capacity, but this has inescapable consequence. Queues, massive queues. Whenever a single process or operations starts to operate towards their capacity, we get queues. Think the cashier at a checkout with a queue of shoppers to process. Emails queuing in your inbox, which keep you permanently busy to reply to. Or unbuilt cars on a waiting list for a factory that's already working at its max. In fact, it's the queue that allows each of these people, processes, operations to be so efficient. When a queue builds up, it lets us be more efficient and not waste time waiting for something to do next. So, queues, always a real thriller, but hold on, queues are not just boring to wait in. Queues are unhappy customers waiting for minutes on the phone, companies waiting weeks for a shipment, or a nation waiting years for a government decision. It's a law of operations science that as we approach 100% capacity utilization, queue times will increase exponentially. So let's think about two great examples of capacity utilization choices and the implicit choices and trade-offs that it brings. The fire and rescue department versus the GP doctor's surgery. These are two great examples on capacity utilization choices and the implicit trade-offs that it brings. The fire service and the GP doctors take a very different stance on capacity utilization due to very different operational objectives. The doctors in the public doctor's office are always busy, 100% utilized. Queues are massive. We often have people waiting weeks to get a checkup appointment and then hours more in the waiting room to actually be seen. But like it or not, this is by design. The goal is maximum output from the resources, the doctors. They are 100% utilized, and so we get massive queues. On this graph, the Kingman law, we'd be way up in the top right. And if these patients were paying customers, many would take their business elsewhere. but for the public doctor's practice, the customers don't have that luxury of choice. Meanwhile, let's look at the fire department. What we want from a fire department is a bit different. Here, we want instant response times. That's the most important thing. One fire department or team might have the ability, the capacity to attend 10 incidents per day. And if the government were to only pay one fire team in the city, a city which has on average 10 incidents per day, all might seem perfect. But this would be an instant disaster. Variation and unpredictability of demand, which is the norm across all sectors and especially for the fire service, means that incidents do not happen equally spaced throughout the day. The demand arrives with no warning, often in big surges. The fire department could deliver their full capacity of 10 incidents per day, but only if there was a giant queue of jobs to buffer the massive variation. This would ensure that none of their time is wasted waiting for the next job, hence 100% capacity utilization, but with big queues. Burning houses do not like to sit in job queues. Capacity utilization is not what we want to be maximizing with our fire service. So what do we want? We want ultra-short lead times and availability. It's by design that the fire team needs to be idle for most of their time, so that when the emergency comes in, bam, they're ready and gone. That means having a queue of 0 and a very, very low capacity utilization, hopefully spending most of their time preparing equipment and training. The GP, surgery doctor, and the fire department are the two extremes. 100% capacity utilization for maximum output, but horrific queues, or very low capacity utilization, or huge overcapacity, we might say, to ensure no queues and an instant response. Every other organization, business, whatever the sector, needs to choose to be somewhere in the middle. And we must remember to be aware of the consequences of trying to just squeeze out that little bit more. Moving a little further up the capacity utilization graph will bring bigger queues. So consider your business operations. Where are you trying to be? What are you trying to optimize for? There is a trade-off. Okay, moving on, constraints. The constraint in your system. We talked about if trying to squeeze the maximum output from your business really aligns with your objectives. Now we're going to look at how to understand and maximize the ability of your operations to be able to produce, to do more. When a business or operations are capacity constrained, as opposed to sales constrained, then the ability to make more is typically profoundly valuable and profitable. We're going to look at the ideas of constraints. What part of your system is the limiting factor? Even if you're not trying to increase output, the ability to understand and increase your capacity output capability is what might allow you to deliver without suffering those huge bad consequences of operating near your maximum capacity, as we saw in the last section. The big operational concept of constraints, sometimes called bottlenecks, is almost universal in its applicability, and it's wildly significant. Let's take any system, a system made up of processes, a productive operation system. Examples might be a burger restaurant, an airport, a software development firm, digging a tunnel, doing medical procedures. In the system, that is a burger restaurant, the steps might include taking the order, cooking the food, assembling the burger, packing it up. In a software development house, it might be scoping the project, gathering requirements, writing the code, testing, and launching. Digging a tunnel might mean preparing the ground, laying the dynamite, clearing away the spoilage, and reinforcing the ceiling. Or in medical procedures, it could be diagnostic, treatment, recovery, and discharge. Each is a system made up of a sequence of distinct processes. Jobs go through the system, are processed into higher value outputs. Every business system that does something, creates value, is made up of a sequence of processes, and one of them is the weak link. The process that has the lowest individual capacity and therefore limits the potential of the whole system. Almost every operations improvement effort of any kind begins with mapping out the system of processes. Let's look at an example in an airport. An airport is an operational system. It's the people being processed through the system, through multiple process steps, which takes several hours. The steps might be, in an airport, simplified down to check-in, security checks, boarding, and takeoff. So what is typically the constraint for the big city airport? This is a little counterintuitive because as a passenger going through the airport full of tedious steps, the least painful part of the process from the point of view of the customer is actually probably the constraint. The runway is almost always the constraint of an airport, the ability to take off and land planes. There are restrictions to getting more runways. You can't just buy more. They would be wildly expensive. The space typically doesn't exist. And changing procedures on how to use a runway is a scale of Herculean global magnitude that I don't think anyone can attempt to tackle. The runway is the constraint. By definition, there is excess capacity for all of the other steps. The runway can maybe only process 10,000 people per hour, but the other process steps could maybe do 15 or 20,000 people per hour. Constraint management is built upon the very practical theory of constraints and its many structured methodologies. One of the key principles when trying to maximize output: keep the constraint running at top speed. Every minute of time on the runway is worth thousands of pounds. Queues waiting to use the runway, are deliberate. Both queues of planes waiting to take off and the queue of planes circling in the sky ready to land. It ensures that there is always a plane ready to utilize every second of runway time. And the air traffic controllers are the ultimate high-stakes operations managers. So let's cover that second topic. A system is made up of sequential processes. There is always a constraint. It could be the cashier station in McDonald's. It could be a particular big expensive machine in a factory, or a uniquely skilled individual lawyer in a law firm. That is the process that has the lowest individual capacity, and it's often not obvious. The activity of mapping out the system of processes and analyzing the capability of each individual process is required. Once we've identified the bottleneck, the first thing is to do everything you can to keep it running at all times, to protect it from external disruptions, to subordinate everything else to its optimum running. For more info on this, please refer to the 5 focusing steps from the theory of constraints. The third topic we'll cover on reducing the chaos and firefighting in your operations is about value. Look at what your business, your operations, your own role, your own job, what does it do? What does it deliver? What is the output? Even if your team or individual role or business unit doesn't deliver a finished good or service to a paying external customer, you still have a customer, a beneficiary. It might be your boss, another business unit, or if you are a charity, the people who benefit from your work. If you're in a hospital, the patients are the beneficiary. Consider what is the output that you provide? What is the value you have generated? A hospital takes in sick people, uses skilled labour, equipment, resources, and creates healthier people. A factory takes in raw materials, applies energy, skill, machines, and produces fabricated goods. An airport takes in people in one country and turns them into people in another country. A software development house creates valuable software. A customer call center takes in inputs of customers with a problem and turns them into customers with a solution. And so on. But the output created and the value delivered is a lot more nuanced. Let's consider, my favourite, a service station fast food burger restaurant. You go in and the output they deliver to you is a burger. That will be £17, please. The value delivered to the customer is a lot more than the burger. There's so many dimensions, and understanding these lets us refine our offer, focus our effort, and capture a lot more value from our customers, focusing on what matters to them. In our service station burger restaurant, what is this output? Well, first of all, calories. I want to buy food. Then it's got to be more than just calories. It's got to taste good. I'm paying for the flavour. Okay, relative. Acceptable nutrition quality. Assured food hygiene. That's about the product. Then there's parts of the service. What else is it delivering? Quick delivery. It's valuable to me. It's more valuable to me as a customer that it arrived quickly. It saved me time. I didn't have to do any washing up. But there's a lot more to it beyond that. I want comfortable seating to eat it. I want to be in a warm, dry room. That room has to be clean, both the space I'm in and the table. I'm paying for the ambience. I want it to be relaxed. I want to have some friendly service. I get value from now the right to sit down and use the power socket to charge my phone, to use the Wi-Fi. Dozens of overlapping dimensions to this output. Focusing on customer value is a foundational principle of lean philosophy, built from the Toyota production system. Our burger purchased from a service station diner is a combined product-service experience, as is almost everything. And different aspects of the output are wildly different in value to different customers. Take calories. Some people, that's the whole point. Others would wish they didn't exist. Good taste, relative, I know, is more important to some than others. Quick delivery might be of absolute crucial value to some customers, whereas others are very happy to spend a whole hour enjoying the service station. Other customers might literally be paying to buy something so that they can sit down, charge their phone, and use the Wi-Fi. Considering all these different aspects of the value that you produce, far beyond just the burger, can allow us to hone in and focus to deliver more to our customers and focus our efforts on how to do that best. I want to tell you about an example from one of my recent consulting clients, where the value of what they were delivering was in fact nothing like what they thought they were. A client of mine ran an industrial oil filtration service, filtering dirty machine lubrication oil so that it can be reused rather than disposed of. And his clients were giant industrial factories, etc., in Dubai. Now, cleaning a single litre of lubrication oil by filtering it, rather than buying a new one, saves about $1. Typically, they're filtering a few thousand litres at a time and charging a few $1,000s for the job, saving that customer a few $1,000s too. But he hadn't realised that the value of these same services was incredibly different for some customers in some situations. One of their clients was a power station. Now, power stations do not like to be turned off and on again. Turning off a power turbine for a single day of maintenance would cost that client a lost profit of $8 million per day, either from unexpected or planned downtime. One of the many causes of such downtime could be mechanical failure due to poor maintenance, lubrication, or clogged parts. So the oil has to be changed, but stopping a turbine for 2-hour oil change would cost $600,000 in lost profit. My oil filtration client realized that in this situation, the value they were delivering was not turning dirty oil into clean oil, but stopping of the turbine to make that oil change, if they could do the oil filtration whilst the turbine kept running. Now, doing this was massively more difficult for the oil filtration team. It would take them 5 times longer and they would need another $200,000 piece of equipment. However, the power plant would gladly pay 50 times more if they didn't have to stop their turbine. The value they were producing was not cleaning oil. What they were selling was downtime prevention, both directly, not having to stop the turbine to clean it, and also the probability reduction of unplanned, unexpected maintenance issues from a breakdown. So consider the output of your own business operations, how you and your team contribute towards them. Okay, and that wraps us up. So, a little summary. We looked at how to reduce the disruption and chaos in your operations, how to have a bigger impact and deliver more with less. We looked at the strategic choice of how busy do you want to be, the huge and non-obvious but inevitable consequence of trying to squeeze in a little bit more. We looked at what determines and limits your operational capacity, its constraint, whether this is to increase output or reduce our capacity utilization for the same output. Finally, to examine the value we create and deliver, its many dimensions. Many are not obvious. Some are worth much, much more to certain customers. Can you deliver or charge for that value that you create and deliver, and make better choices about what is really worth focusing on?